So I hope you all know that anything that does not grow has to be mined. So from planes to cars, even the electronics in this mic, to the needles of the vaccine we're gonna get someday, everything is a derivative of mining. It's either coming from mining or it is being derived from a product of mining. And due to increasing population, urbanization, and a lot of reliance on electronics, mining industry has a lot of pressure to provide a sustainable and constant supply of minerals. And how do they are getting this problem? By increasing the size of mining machinery. So if you look at, I think on the right side, you can see a big bucket. So that's a bucket that can lift around 73 tons of soil in one scoop. That's more than enough to fill in a king-size bedroom. So when we have this much big machinery, we need processing and analysis of this machinery. So my research topic is related to the design and analysis of this bucket. And whenever we think of design, the first thing that strikes our mind is computer simulation or a computer model. And I think most of you might have seen those fancy computer models that in some sort of a movie or documentary, but to make sense out of those models, you need to have a rigorous experimentation plan. And that sort of experimental plan on this much big bucket is financially and physically not feasible. It takes in a lot amount of money and resources to conduct that. So how I solved this problem? I solved it by building a scale model. So I built 1:16 size scale model. You can see at the top on the left. So this, and I did intensive experimentation on it for 7 months. So I tried to cover in all the design aspects that are needed for an efficient design of the bucket. And once I had all those numbers, I used those numbers and built a valid computational model. And at this point, I'm trying to analyze different new designs of a bucket prototype and testing how, each different iteration works better, or which iteration works better for us. And by the end of my PhD, I will be able to come up. So right now, what I have 2 designs that I'm showing in the presentation that are showing promising results. And at the end of my PhD, I aim to patent them with all the technical and good information to back them that they work better. So that's all. Thank you.